What do we mean by radicals? Radicals is the symbol that is used to denote the square root or the nth root. Now look at it when you have something like this. We are conversant or familiar with this. This is square root. We don't call it square root. We can also call it radicals. Now, if we have this x, I have here n. We call this x here, we call it radicand. This is called the radical symbol. And here is called the index. Meaning, if we have something like this, let's translate this to numbers. So that means this 3 here is the index, 3 is the index, 27 is equals to the radicand, 27 is equals to the radicand, and this is the radical symbol. So those are what we need to understand about radical. There now, if it is this, we call it square root. If it is this, we call it cube root. But let's discuss a case where we have this our index to be 4 or any other number apart from 2 and 3. Now, when it is square root, you don't need to include 2. When we have something like this, referring to the square root. So in that case, we don't need to include 2 here. So when we have this, we know that that is referring to the square root, and we have that is referring to the cube root. Like I said earlier, if it exceeds beyond 3, how do you name them, or how do we call them? This, we call it square root, which also is same thing as s raised to power 1 over 2. If we have this 3, we have 3 as index here, we call it cube root, and that's s raised to power 1 over 3. If we have it here, x, and the index here is 4. Now, after 3, we call them in the ordinal form. We call them in terms of position, the ordinal number. That means we call this fourth root. That is s raised to power 1 over 4. If the index is 5, we call it fifth root. That's s raised to power 1 over 5. If the index is 6, we call it sixth root. That's s raised to power 1 over 7. If the index is 7, we call it the seventh root. That's s raised to power 1 over 7. If the index is 8, we call it eighth root, which is same thing as s raised to power 1 over 8. If the index is 9, we call it ninth root, which is same thing as s raised to power 1 over 9. And if the index is 10, we call it the 10th root, and that means that's s raised to power 1 over 10. Here, if the index is n, where we have n here, we are going to call it the nth root of x, nth root of x, which it means x raised to power 1 over n. So the summary of it is when the index, the n, is greater than 3, that's when you have beyond 3, 4, 5, 6, we call them in the ordinal form, we call them in position. 4th root, 5th root, 6th root, 7th root, 8th root, 9th root, and 10th root. Let's just take some. Let's just take some numerical examples to show or exemplify some of them. E.g., if we have square root of 4, that's going to give us 2. We have square root of 49, that's going to give us 7. If we have cube root of 8, that's going to give us 2. Also, we also have cube root of 27, that's going to give us 3. Here, what we mean by square root of 4 here means that same number that we will multiply by itself is going to give us 4. That's 2. Here, 7 times 7 will give us 49. Here in the cube root of 8, here we have numbers that we can multiply by itself 3i's. That means we can have 2 times 2 times 2, and that's going to give us 8. 27 as well, we can have 3 times 3 times 3, and we have 27. That means that's what this is saying. Cube root of 27 means that particular number that when you multiply by itself 3i's is going to give us that. We have 4th root of 16, that is 2. That is 2 is that number that you can multiply by itself 4 times to give us what? 16. #81 equals 3. 4th root of 81 is 3. That number that can multiply by itself 4 times, that is 3 times 3 times 3 times 3, is going to give us 81. 5th root. So you take the 5th root of 32, that's going to give us 5. That number that you can multiply by itself 5 times. 5 times to give us 32. The number is 2. 2. That you can have 2 multiplied by itself in 5 times. That is, we can have it to be 2 times 2 times 2 times 2 times 2. That's going to give us 2 raised to power 5 in the index from 1, 2, 3, 4, 5. So this is going to give us 32. So we have 32. We can also have 2, 5, 3. 2, 4, 3. That's going to give us 3. Let's take another one. If we have the 6th root of 64, it's going to give us 2. We have 7th root of 128. 7th root of 128. That's going to give us 2 as well. We have 8th root of 256. That's going to give us 8th root of 256. That's going to give us 2. Then proceed to 9, 10. Let me leave us with this in the comment section. Let me leave us with these questions. So we leave the answer in the comments section. If we have 10th root of 5, 9, 0, 4, 9, what's going to be the answer? Here we have 9th root of 5, 1, 2. What's going to be the answer? Kindly drop your answer in the comment section. So with this, these are basic things that we need to understand about radicals. Radicals are symbols that are used to denote root. If we have 2 at the index part, we don't need to include the 2 if it is 2. We call that square root. When we have 3 at the index part, it is called cube root. If we have 4, it is called fourth root. If we have 5, it is called fifth root. If we have 6, it is called sixth root. If we have 7, it is called seventh root. If we have 8 root, it is called eighth root. If we have 9, it is called ninth root. And we have 10, it is called 10th root. And if we have n, it is called nth root. And extend like that. Even 11, 12, we call it in the ordinal number in positions. If you have find this video helpful and useful, kindly share to friends and colleagues. Don't forget to subscribe, like, and share. Thank you.